Hello and welcome to another video on autonomous agents. I'm going to talk about how to build autonomous agent with multiple tools. In the last video, I was talking about building a RAG application, and we saw some strategies how to improve the output from the RAG application. Now what I'm going to do in this video is I'm going to take the same RAG application, use it as a tool along with other tool like search tool. For example, if I want to search something on the internet, so I'll use these couple of tools, build an agent and try to ask questions and see if I need to combine everything together, how do I get it working, and what does it require for me to build such kind of application which we call autonomous agents. So before I get into technical details, I want to call important thing like the important thing about how these agents are helping in doing multiple tasks at a time. For example, you can have one agent give multiple access, for example SQL tool, search tool, or the tools like the one I built a RAG application and ask the question. It will automatically figure out which tool to use for answering the question. That's the intelligence which we are going to see from. Basically, intelligence is coming from large language model, but on top of that we are using the reasoning capability of LLM to build autonomous agents. So let's get into the technicalities, how to build one, and then see how it efficiently returns the data by looking into the available tools. And it's not like it is just going to use a tool and get me the output. It is going to take step-by-step approach, getting the response, validate it, and see if the response completely answers the query which I originally asked to the application, and then have an intermediate state and then come back and give me the proper response. So let's get to this implementation. First we'll look into how to build this autonomous agent, and then we will use it with few questions and see how it is switching between different tools by intelligently understanding that this tool is not giving me the answer, so let me go and ask some other tool. And we will also see how much tokens or how much of the utilization of the data between application and large language model, which is exchange of tokens, happened during this whole conversation. So let's get started. So here's the application which I'm going to use. I think I already talked about it. LangChain is something which is quite popular in building chains, which means you can have a RAG chain, you can have a simple prompt and then output. Plus now we are going to have agents. Now agents are basically nothing but they are cyclic graphs, because when you give some input to an agent, which is a query, now agent has to come back with some response, and it may ask for two things, like if the response is okay, or should it continue further research or try to do something different. So basically to and fro communication will happen. So that's why it's cyclic graph. Now this is the same concept on which LangGraph is built. This is a library on top of LangChain. I'm going to use it. So key concepts behind it is that it is having a state graph, which means the state state variable is something which is maintained as and when agent is taking some action, it is maintaining a state. For example, it called some API, got the data, it will write it and see that this is the data response I got for this particular action, which means calling the API. When it want to ask, okay, what should I do next, means what is the next action, then next action may be influenced by the previous actions output. So it means it needs to know somewhere it needs to write or save this information, which is we call it as a maintaining the state. So that's what this state graph is about, which is a variable implementing the state of the agent agent actions. So let me go to the application here and I'll explain step by step what we need to build this autonomous agent. So I have this application agent app, and let me start from the two key things. As I mentioned that I built the agent app not just to run it, but I have very specific purpose where I want to ask similar question which I was asking in my previous video to the RAG application, and that was here. Let me go to the main application. That was what. So these are the two questions we will be looking into in this video. So what are the autonomous agents? Explain me step-by-step process to build an autonomous agent using LLM. So this is the question which I'm going to ask. Now what do we need to build this one? So first of all, we have these 4 classes or the 4 scripts which we need to come up. So let me start with the graph script. Now, as I mentioned, this LangGraph is nothing but a form of, basically the problem is nothing but a cyclic graph. So there is the model called state graph which we need to initialize, which is nothing but the workflow, and then pass the agent state. Initially agent state will be none because agent has nothing known about it because it is just starting. So this is the agent state script, which is a class. So we give an input, and then whenever agent runs, agent action takes place or agent is finished. So we just capture it as a agent outcome and combine it. So and initially it will be none. And a second important part is intermediate step. So because agent is not going to give me response immediately as I ask the query, it is going to take some steps to drive the output. So what are the intermediate steps it has taken? It will add it as a list of agent actions, and there are 2 basically flavors of it. Either I can overwrite the previous steps information with a new step information, or I can keep appending. So I'm using right now the operator .add, which is appending. So coming back to the graph, so once I have the state graph defined with the agent state, then I need to add nodes. Now agent nodes, the nodes are basically 2 important nodes are must for agent the LangGraph application or to work upon. One is the agent, which is running the agent, so which is nothing but the process, and then the action. Now agent action is what? Agent will be having some tool, some one or multiple tools, which we call an action here. So that's what here I call an execute tool. And then you can also have another step or another node which you can say, whenever I start this application, I want this node to be used as a first node, as an entry node. That's what I'm using, this first agent. I'm just naming it first agent. It could be any name. So I'm setting it as an entry point. So when an application enters in a graph, this is my first node which is going to be invoked. And now we have added nodes, then we need edges to connect those nodes. So action node, if action is there, every action will return the call to agent. And if agent is running or a first agent is running, it will give a call. Basically, if I run this node, it means the entry point is first agent, which is the first node, then it will take some action. So it will connect to the another node, which is action. Action is nothing but a set of tools. So this is how it is connected. And then there are conditional edges. So we have this add conditional edges function where we pass agent and function called should continue, and we pass these. This is the dictionary, which is continue. It means take action. If it is end, then means end. And here it is. Here we have the details of this should continue. Let me go here. So this is a graph nodes. We were looking at the graph, so now I'm going to graph nodes. So execute tool, all the functions, basically whatever I have shown here, run agent, execute tools, first agent, and then should continue. These are all functions. So these are defined here in the graph nodes. So rest are run agent is nothing but your agent executor, basically a large language model you invoke. I'll just quickly show. We take the prompt. I'm using a large langchain default prompt, whatever is available on the website, and then using OpenAI chat APIs, and I'm using GPT-3 model. And then I'm passing the couple of tools, search tool and report tool. Report tool is the one which I'll be using as my knowledge base, which is RAG, and search tool is internet search. I'm passing all these things and creating an agent executor. So this is again a langchain concept or syntax to create a LLM instance of LLM. Then we have execute tools. Execute tools, we just need to pass tool information. For example, tool executor is one class here. I will just go to here, tool executor here. So, and then I have a tools defined here. Search tool, get data from PDF. So go back to this one. So tool executor will have a function called invoke, and then it will start storing the information about agent action and writing the response. The important function is should continue, which means if the agent outcome, so I will show the response when I run the application. If the agent outcome has, say, agent finish, then basically we're checking the instance. Then we say, okay, agent finish means agent is finished its execution. Then we return end, and end means the agent's process will stop. And if it is not the case, then it will continue, means it is just at the intermediate step, it has to continue next step. So these are the four. I covered all: graph, nodes, state, which is just persisting the state for each and every outcome, and then executor is just an instance of large language model. Now when we have all these things available, we have a application which is an autonomous agent ready. This is all we need. And apart from this, we also need tools. So I'm defining a couple of tools. I think I already covered, but let me quickly run this thing again. So I have two functions: get search tool, get data from PDF. I have to give a description so that agent or basically agent or large language model can understand from the description, what this tool is about, and appropriately call based on my query. It will figure out, okay, this query requires search to internet, or this query requires search to my PDF or my reporting tool. So this is the reporting tool. So I built that, and this is the reporting app is nothing but the same RAG app. I just wrapped it in a class. The function basically as a underscore means private function, and same logic, same template, prompt. Then I'm using vector store, retriever, and last in video I was using OpenAI embedding, so for retrieval and as well as for indexing. So we'll not run indexing because I have already run the indexing part here. So my data is already indexed, and I'll quickly show you. For indexing, I have used the same class, same script. So here is that load. Okay, I have loaded this LLM architecture overview. In case you have not seen the previous video, I can quickly go and show you the PDF which I was referring here. Just give me a second. Here is the one. Okay, so this is the document which I used in the previous video to ask the question how to build autonomous agent and give me step-by-step process. So I'm using the same document again. I saved it here. I have already indexed it. Now I'm going to run the agent application and ask this question to agent. Now agent will figure out which tool to use, and I have configured agent to set that whenever I ask any question, use first agent, which is first agent is nothing but this one. Use reporting app as a first tool. Means reporting app means my knowledge base, RAG application. So don't just by default go to internet or randomly start searching in other tools. Always use my reporting app as a first tool for my query. If you don't get answer, then go to other one. And I don't have to tell all these things. Agent will figure out. All I have to tell is my preference is my first tool should be, or the default tool should be reporting app for my application. Now let's go back and run this application. So here is the agent app. This is very simple function. I'm asking this question: what are the autonomous agents? Explain me step-by-step process. I'm printing the input here, and then I'm just creating instance of get graph and stream. So it will keep streaming the data for me, and we'll see the output whatever I'm printing here. So let's run this. So clear py app graph with agent executor. Right, so this is a question it printed. It is using the reporting app, which is correct because this answer will be coming from the knowledge base. Okay, it is still running. Let it continue. Let it finish, then I will explain the output. Okay, so let's go back here. Fine, so we got this value, agent outcome tool to use reporting app with the tool input as this is the question which I'm asking. Then it ran the tool. Basically tool was RAG application, and excuse me, it used this same question to answer my query, and this is the output. So here is the output we got. I think something similar which we got in the previous video, because this is referring to the document, and it gave me 5 points: planning and reasoning, training and fine-tuning. I just read it out in case you have not seen the previous video. So here it is saying autonomous agents are AI entities that can operate independently, making decisions and taking actions to achieve specific goals without human intervention. These agents are equipped with cognitive controllers known as large language models that enable them to generate plans, reason about tasks, incorporate memory, adapt based on feedback from the environment. And to build an autonomous agent using LLM, you would follow these steps. So planning and reasoning, training and fine-tuning, feedback mechanism, multi-turn instruction, deployment and integration. So this is the response we got from tool. It has captured this information. So intermediate step, it says, okay, this is the tool I got, this is the response I got for the query, and then it will internally it will try to write it some information, and finally this is the value it got, and out of this value I'm printing the output, the end value. So final agent response is same which I think we saw from the RAG tool. So planning and reasoning, training and fine-tuning, feedback and all. So we got the answer, I think, which is appropriate. We already see the document. I'll quickly show if someone wants to see that control F. Okay, so here is the one section which talks about next one. Yeah, so this is a section which talks about LLM powered agents, and it has this one: respond to dynamic scenarios that made it possible to incorporate them in diverse applications. So LLMs steering autonomous agents. LLMs are cognitive controllers. They generate plans, reason about tasks. We saw this was mentioned in the response. And then module and strategies employed in autonomous agents are planning and reasoning. Then we have feedback, and after that we have memory. LLMs can learn from the context provided in the prompt. Fine. And then multi-agent systems and physical environment. So this is, I think we got a almost correct answer from the reference, which is the knowledge base. I don't think it has deviated or it has built or made up itself any part of the response. Now what I do is, now I ask another query. So I just comment this out. I am asking now, what is Sora AI model by OpenAI? Explain me its architecture in detail. Okay, so this is the question. I'm going to run this same application. Okay, it will take a little bit time. Okay, so it started running. Alright, so we got some response. Let me see. Okay, so first let's see what did it do. First of all, it said, okay, this is my action. So it's called reporting app, because I mentioned that reporting app should be my first preference for answering, figuring out the answer for my query. So I tried to call it. Then output came. I'm sorry, but the context provided does not mention any information about the Sora AI model by OpenAI. So it means the RAG tool did not give me response, did not give a response. So agent understood. So agent got the message. It actually, this is the intermediate step. It wrote it as a log that this is the response I got when I asked this question. Then it use the prompt. Then it started. It picked up another tool. Tavily search result. JSON Tavily is the library. I think they are working very closely with LangChain and giving us support for any kind of Google or internet search. So you just create an account and get the access to the API. Although it's paid, but there are a lot of free tokens or free credits available. So this is the one which is used. Then it run this query. We got some response here. Content something is mentioned. So I think I will just quickly show the end result. So the Sora AI. Okay. So here it says the Sora AI model by OpenAI is a text and video generator developed by OpenAI. Unfortunately, OpenAI has not released much information about Sora's development and training, and the company declined to respond to most inquiries. As a result, detailed information about architecture is not readily available. Okay, so fine. I think we need to see what access it got. So it maybe would have picked. So let me go to tools. So here when I'm searching it, I'm saying max result 1. So let me change max result, let's say 5, and let's see if it is able to answer now, because it got only one response. That response probably was giving the same information. It does not have any information about the architecture, so it is not having anything in information release. It's private and all those things. So let me start it again with the same question and see if I get multiple results, and from that result if agent is able to give me the meaningful information what I asked. Okay, here we got some response thing. Okay, cool. Let's see what does agent get out of it. Okay, now we got something. Sora AI model by OpenAI is extraordinary AI model capable of transforming simple text description into dynamic realistic video. It is text to video generative AI model that has the potential to generate. Okay, cool. So then the model is trained to generate videos based on descriptive prompt as well as extend existing video forwards or backwards in time. Then OpenAI has implemented several safeguards to ensure responsible. Okay, so this is about safeguarding, but I think it once again, did I get the answer for the architecture, because I asked explain me the architecture in detail. So for more details about architecture Sora, you can visit OpenAI website. Okay, so it has just given me the links. Go there. Maybe it looks like it did not get the relevant source which explain about the architecture on the internet. So whatever it got, it just sample it and given it to me. So this is whole agent application, and it is also showing here the sources which it is using. For example, OpenAI Sora, it is the one which it used to get the data. Let me ask some other question quickly and see how good it is, agent application. So I'll comment this out. I'll ask it again some. Okay. What are the key takeaways from Bill Gates India visit in March 2024? Okay, so this is Bill Gates is in India, so he's meeting a lot of people. So let me ask this question and see if we can get some information, because this is just the news information. Okay, so waiting for this call. It called again, reporting app. Fine, it will come back. It says that I don't have any context. Then it's calling the table. Okay, so now it is calling different link. Hindustan Times, Times of India. Okay, let's see what does it get. Okay, here. So Bill Gates visit to India in March 2024 included discussion of various key areas such as digital public infrastructure, artificial intelligence, women-led development, innovation in agriculture. Bill Gates also expressed admiration for India's effort in enhancing economic growth, technology advancement, and also. So basically, I think since I asked key takeaways, so I think it has just talked to me and given me some pointers. If you need more details, I can provide specific details on the sources. That's what it mentioned. So what I mean to say is, so agent is working automatically, figuring out which tool to use, where to get this data from, and how to provide the output, making relevant to the query. So that's a key thing here. And more important thing is, the whole agent response is driven by the prompt which I'm using. Right now I'm using a default prompt from LangChain, but we can make specific, we can make an agent to play a specific role. For example, if I want some kind of drill down details on any of my query input, so I can mention it in a prompt and it can go ahead. I can give him a structure. Okay, when you give the response, give me the bullet point, put a summary first and give me the bullet points, and then summarize the whole context. So that is all about prompting. So I'm not using that here. I was using the default prompt which was provided by LangChain, but we can always modify and have a customized prompt to get the better response for our application. So this is, I wanted to show the power of autonomous agent using cyclic graph problem which is solved by LangGraph in a very easy manner. And the last part is how much tokens are used when I was asking this question, because a lot of data was exchanged between the application and large language model, which is, I think I was using GPT-3, but was it asking, sending the complete context, whatever it was recording on its intermediate steps, or it was only sending the relevant information? So that is internal. We are not able to log it. There is this way we can use different tool to get those stats as well, means what kind of information is exchanged between large language model and the application. But at least I can go to my OpenAI account and look at the usage for today's date, which is 5th of March, and then we can figure out, okay, if I'm using this application, what is the cost I'm going to incur. So I felt the response from the application, which is autonomous agent, was great. It was a simple application. I did not do any kind of major customization and just provided a couple of tools, basic tools. One was a RAG application, which was again a basic application in itself, and then the search tool for the internet. But if we have specific use cases, we can customize it to the level way we need data in production, the kind of detail we need in production. So this is what I want to talk about in the next video, how to build a production grade application. Maybe build one, have end-to-end implementation, deploy it over the infrastructure, which is a production grade infrastructure, then measure the cost metrics. For example, running this model or running this application on the production grade hardware, and the latency check or the accuracy of the data which we are getting back from the large language model, trying out different models, and finally the cost which we are incurring over the whole application, whole deployment or whole hosting of this application or execution of this application. So I will be making another video on that. So till then, goodbye and see you soon.